Topic 9 talks about data analysis and statistics. Statistics is known as the study of the correlation, organization, analysis, interpretation, and presentation of data. It's also known as telling a story with data. The mean can be defined as the sum of I equals 1 to n times 1 over n, and it's the central tendency or the average of all the values, and its function in MATLAB is the mean of x. The median can be defined as the middle value, and its function in MATLAB is median of x. The mode can be defined as the most frequent value, and its function in MATLAB is the mode of x. The next statistical measurement is standard deviation, which measures the variation from the mean, or the spread of the data. The equation for standard deviation is 1 over n minus 1, so 1 over the element number n minus 1, all times the sum from I equals 1 to n of x of I minus the mean of x squared, and it's the square root of all of that. The function in MATLAB is std of x. The next statistical measurement is variance, and it's the same equation as standard deviation, just without the square root. So it's the sum of x of I minus the mean of x squared all over n minus 1. And it measures how much variability is in the data, and in MATLAB the function is var in parentheses x. Covariance, which is kind of like variance, but instead the equation is the sum of I equals 1 all the way to n times x sub I minus the mean of x times the y sub I minus the mean of y all over n minus 1. And it's measuring the strength of correlation between two data sets, so you need an x and a y. So the function in MATLAB is COV in parentheses x comma y. It's correlational coefficient, which is basically the covariance all over the square root of the variance times the covariance. And the equation for this is the sum of x sub I minus the mean of x times the y sub I minus the mean of y, all over the square root of the sum of x sub I minus the mean of x squared times the square root of the sum of y sub I minus the mean of y squared. And in MATLAB, it's core coefficient of x comma y, which the function would be CORRCOEF, core coef of x comma y. And it finds the correlation between data. This example shows good correlation versus bad correlation. So bad correlation is on the left, where it has no correlation at all. You can see it's 0.0 of monthly sales by traffic count. And on the right, it's closer to 1, so it kind of has a really good correlation because the dots are more in a line, but on the left, they're not in a line.